So here is question 2. So Ohana, who I actually got an email from today, she used to be head TA for this class. She's playing with her dog, Rum, who is in fact named after the drink that we call rum, and they call rum in Brazil because she's Brazilian. She kicks Rum's ball like that. It leaves the ground at an angle. Doot. That's the initial velocity vector. And the angle above the horizontal will be this one in yellow. I keep dropping and breaking my chalk, is theta. So there are no numbers in this problem. Detmalk, so we were a couple people who are live on Twitch here. Detmalk says that they suffered a lot on the homework. The homework is supposed to be challenging, right? The dog and your cat in the elevator problem always provokes a huge amount of conversation. But that problem, like once you've done that, interpreting the quadratic formula as you did on the quiz is a piece of cake. So in this problem, we want to know how far Rum's ball goes. Ready for my new box of chalk ticket here. So we want this distance, and we don't have any numbers. So how do we do that? Well, what I'm going to do, I'm going to kind of do this in stages. I'm actually going to do part B on the quiz first, and then go to part A. The question I'm going to be answering the whole time is what is the value of x of t at the same time that y of t equals 0. Because I know that as the ball flies through the air, right, if I choose this point here to be my origin of coordinates, then I know that as the ball goes up and comes back down, that there's some moment in time when the ball reaches the point d, comma, 0. So I want the value of x at the time that y is 0. Well, all right. That tells me I need expressions of for x and t, x of t and y of t. So let's write those down. Boop. I know you all make fun of me for saying boop too much. So the initial position, we'll write down the most generic thing. Let's see, this is going to be the initial position term. Shall I write that in white? We'll see why in a minute. The initial position term plus the x initial velocity times time. Time shall be green. And then there is an acceleration term, 1/2 ax t squared. Similarly for y, I have the same thing. I know y of t. This is going to be y naught plus, I'm just thinking about what color chalk I want to use for this. We'll use the orange chalk here, plus v naught y times t, plus 1/2 ay t squared. I can't wait to get more colors of chalk. So in these equations, we know that many of these terms don't matter. So since I've chosen my origin to be here, I know this is 0. I know this is 0. I also know that I'm only accelerating in the y direction. So these three terms, the only ones that survive, and I know the acceleration in the y direction here is minus g. I'm going to choose the conventional coordinate system where y goes up and x goes to the right. So now what I'm going to do is I'm going to recopy these equations over here on the board with only those terms that survive. So, what do I have? I have, oh no, I shouldn't have used, I used the wrong color. Damn it. We use this, make this be orange. X of t. There we go. So, x of t, I've got the initial velocity term. V naught x times t. And then I have, this term has gone away. All right, that's nice and simple. Position bit, let's see, so I'm starting at ground level, so I have a velocity contribution and then a gravity contribution. So this gives me V naught y t, and then the gravity part, minus 1/2 g t squared. Okay, that's nice. But I have these things hanging around, right? So this is part A of the problem. I don't know the initial velocity's components. I only know its magnitude and direction. So I'm going to come over here as a sidebar, and I'm going to say, I'm just looking at the camera monitor to make sure I have enough room. Not room with the dog, but room on the board. I never have enough room. Ohana, if you're there, I miss your dog. Miss you too. Ohana was head TA for this class in spring 2019. She's now a research graduate student, research associate at the Fermi National Accelerator Laboratory in Batavia, Illinois. Where she still has her two dogs, Room and Quanta. Quanta is very small and Room is huge. So here's the initial velocity vector. I know its length, and I know its angle above the horizontal. But what I need to know are its x and y components. So the x component, let's see, this is the adjacent side. So cosine is the adjacent, and sine is the opposite. So V naught y is V naught sine theta. So that means I can put those in here. So let's do that. I've got plenty of Blackboard. So we don't need to erase, we can write new lines. Components for the initial velocity vector. And this gives me x of t is V naught cosine theta times t. And y of t, whoop, just messing up my color coding scheme. Y of t is V naught sine theta times t minus the gravity contribution, minus 1/2 g t squared. Now, remember what we were trying to do. We're supposed to find the value of x at the time y equals 0. This is the crux of the whole problem. I'm supposed to set this to 0, solve for time. So Set that to 0, solve for the time. Okay, because that's the time when the ball lands back on the ground. So I have 0 equals V naught sine theta times t minus 1/2 g t squared. I'm going to make all the mathematicians in the room itch. Normally you'd say I can't divide by t because it might be 0, but I don't care about what happened to t equals 0. I know 0 is a solution to this equation. I just don't care. So I can cancel with t. I can divide both sides of the equation by t by crossing those out. And then this gives me, so I will do the algebra in full detail here. It's not bad. I'm just going step by step. So this gives me 1/2 g times t, because I've brought that over to the other side, equals V naught sine theta, telling me that in the end, let's see, so I need to divide by 1/2 g, which means I multiply by 2 and divide by g. So this gives me t equals, and here I'm going to switch to just writing all of this in green, t equals 2 V naught sine theta divided by g. Okay, does this make sense? Yes. So I know V naught sine theta is the vertical component of the ball's velocity. This tells me the ball was in the air longer if I kick it harder. Tells me it's in the air longer if I kick it up more, because sine is an increasing function for small angles. And it's in the air shorter if gravity is stronger. All right, everything checks out brain-wise. So now what was I supposed to do? I'm supposed to find the value of x at that time. All right, I found the time. Right? Here's the time that y is 0. So now I'm supposed to find x at the time that I just found. Well, that's pretty easy. That just means I multiply it by V naught cosine theta. So that means the distance is going to be V naught cosine theta times t, which was 2 V naught sine theta over g, which, if you just combine stuff, gives me a distance of 2 V naught squared cosine theta sine theta all over g. That was the thing we came here to find. So I see there are a couple people on Twitch. Are there any questions about what we just did? I know this looks like a whole bunch of algebra, right? But that's just because I've been being very, very step by step. So what I'm going to do is I'm going to clear off some of my extra algebra and make it even more simple. So we know x of t is V naught cosine theta times t. We know y of t is minus 1/2 gt squared plus V naught sine theta times t. So, what did we do to solve the problem? All we did was find the time. Oops, my eraser didn't quite go. So let's find t. when y equals 0. So we said 0 equals this bit minus 1/2 gt squared plus v naught sine theta times t. We solve this. We get t equals 2 v naught sine theta over g. And then we just found x at that time. Now the very last part, the extra credit part, was convince me that a 45-degree angle gives you the maximum distance of flight. So we've got this formula, we can now make the other stuff go away. Convince me that a 45-degree angle maximizes this. And this is where, I'm just going to recopy it off the board. This is where you use the trig identity that I gave you on your reference sheet. You say that's the same as v naught squared sine 2 theta. That's why I gave you that trig identity. And then you say, but I know that sine has a maximum at 90 degrees. So sine theta max is 90 degrees. So sine 2 theta max is theta equals 45 degrees. And that's all. That was the quiz. I know I kind of belabored this one. I wrote all of the algebra steps, and then I wanted to erase them and make it more plain. So thank you for anybody who's watched to the end of these videos, and thank you for the 2 people who are chilling on Twitch watching this. I will make these recordings for everything going forward as much as I can. I don't promise that I can do everything because there are a lot of things I have to do. But I hope to record as many homework problems and as many recitation problems as I can. And I will try to record them all live so people on Twitch can ask questions as we go. I'm going to hang up the recording now, and this hopefully will be the first of many videos like this. See you people who are on Twitch. See you all.